Hi, this is a lecture taken from my online course about the Apache Spark certification, which is offered by Databricks. It handles one of the topics that you need to understand in order to get certified. So check it out. First, let's take a look into how computing is handled in general. On a single computer, we have computing resources, such as the CPU, the RAM, or the GPU. We also have an operating system that is running and multiple applications. The operating system is responsible for resource management, so it takes care of resource scheduling and decides how much resources each application can use. For example, it decides the amount of CPU or memory that an application can use depending on the other applications also running on your computer. To process big data, we need more compute resources than a single computer can provide. That's why computer clusters are used to process big data. A computer cluster is a set of computers that are connected and work together so that we can view them as a single computer. And all the computers involved in a cluster are connected through a fast network. And also on each computer running in the cluster, there's an operating system running. On a single computer, the operating system takes care of resource management. On a cluster, there is a dedicated application for resource management, the cluster manager. The cluster manager provides the mechanism to work with all the resources available in the cluster. And to get an application running on a cluster, we must go through the cluster manager. So the cluster manager has the following task. It will track the resource allocation across all the applications running on the cluster, and will also check and monitor the health of the individual machines in the cluster. The cluster manager is able to manage all the computers in the cluster because on each node in the cluster there is another process running called the node manager, and the node manager has the following task. So they will monitor the resources available on each node and report that back to the cluster manager. And they will also monitor the physical health of each machine and also report that back to the cluster manager. The node manager also check if an application running is running smoothly or if an application crashes or not, and also report that to the cluster manager. So as we can see here, the cluster manager and the node manager forms the operating system of a cluster. To get an application running on a cluster, we must ask the cluster manager for resources. So let's see how we can do this for an Apache Spark application. A Spark application has two logical components, the Spark driver process and a set of Spark executor processes. The Spark driver process decides what to do and the executors do the computation. To get a Spark application running on a cluster, we use the Spark submit command and specify the configuration for our application. In our case, for example, we want the Spark driver process and also the executor processes to have 20 GB of memory and 4 CPU cores. The workflow to get an Apache Spark application running on the cluster is the following. The first step is to submit the application to the cluster manager along with all the configuration. The next thing, the Spark driver process needs to be started, and the cluster manager will request the node manager to start the driver process using the configuration that we specified during application submission. So in this case, 20 GB of memory and 4 CPU cores. If the node manager has enough resources, then the Spark driver process will be created. Now the Spark driver process will then request the cluster manager for additional resources to run the Spark executors. And we can see that it will do that using the same parameter that we used during application submission. So a total of 3 executors, and each executor should have 20 GB of memory and 4 CPU cores. So next, the cluster manager will then request the node managers to create the executors processes. And when the node managers have enough resources to fulfill that request, then the executor processes will be created. In our case, we can see that there is a node with enough resources to run 2 executor processes, and one node can only run one executor process. When the executor processes are successfully created, the node managers then inform the cluster manager about the network location of the executor processes. Now, the cluster manager informs the driver process about the location of the executor processes, and from now on, the Spark application is up and running. Now that the Spark application is running, the Spark driver will start sending tasks to the Spark executors. All the logic specified in your application is sent to the executors in the form of a task. For example, if you would like to read a file, then Apache Spark will then send multiple tasks to the Spark executors to read the file in parallel. And as you can see, we will have multiple nodes or machines in a cluster on which different executor processes are running, and they can all read the file in parallel. And this allows us to achieve a higher degree of parallelism than a single computer can provide. The Spark driver process is at the heart of the Spark application, and the deployment mode of a Spark application specifies where the driver process will run relative to the cluster. There are multiple deployment modes. The first one we are going to look into is the cluster mode. In the cluster mode, the Spark driver runs on a node inside the cluster and the executor process also. So the cluster manager is responsible for maintaining the node on which the driver process is running and also the nodes on which the executor processes are running. This is the deploy mode cluster. We specify that with the parameter deploy mode during application submission. We can also decide that the Spark driver process should not run inside the cluster, but outside of the cluster. This is what we call the deployment mode is then the client mode. So when we deploy Apache Spark using the client mode, the Spark driver will run on a machine that is not part of the cluster. And because the Spark driver runs on a separate client, that client is responsible for maintaining the Spark driver process, and the cluster manager will maintain the executor processes. So the client needs to be alive for the duration of the Spark application so that the Spark driver can also stay alive. If the driver fails, then the Spark application will also fail. And last, we have what we call the local mode. In local mode, Apache Spark will run on a single machine, and the driver and executors will run as separate processes inside the same machine. This is usually how Apache Spark will run on your laptop, or if you decide to run it locally on any server. A Spark application has two components, a Spark driver process and a set of Spark executors. Now let's list the main function of each component, starting with the Spark driver. The Spark driver is responsible for the resource requirement of the application, so it will work together with the cluster manager to get the resources necessary to start executor processes. The Spark driver will also increase or decrease the resource consumption of the application depending on how the application is running. It is also responsible to get the application working in parallel across all the clusters, so it will distribute and schedule the work across all the Spark executors. If a node in the cluster failed or an executor process failed, then the Spark driver process will request additional resources from the cluster manager. And also the Spark driver will track the status of all the executors and also monitor their progress. It also responds to user or program input. Now let's see what's the function of an executor process. And an executor process executes the task assigned by the Spark driver, and it then reports the status of the task back to the Spark driver. And that's all an executor process does. It will take the work assigned to it by the Spark driver, execute the task, and then send the result back to the Spark driver. We've learned how Apache Spark runs on a cluster and what are the main components of an Apache Spark application. If you enjoyed this video, I think you will also like the entire course. The course covers all the topics you need to pass the exam, such as understanding the basics of the Apache Spark architecture, how to manipulate columns in a data frame, how to filter columns or rows from a data frame. It also covers how to work with user-defined function and Spark SQL functions. The course contains over 4.5 hours of video, and you will also get a Databricks notebook that you can import directly into a Databricks workspace to easily follow all the instructions and all the code exercise. It also contains more than 40 quizzes that will help you prepare for the exam. So use the link in the description below to join the course and get certified. Thank you.